And now, dear students, we are going to know when to use the sign of a function and where do we use it and why do we use it. We use it to solve inequalities that are of the second degree. So solving second degree inequalities with one unknown need the idea of signs of quadratic functions. The second degree inequality with one unknown has the form of ax squared plus bx plus c greater or equal to 0, or just greater than 0 without or equal, or less than or equal to 0, or just less than 0 without or equal. And here is the first example. Solve x squared minus 6x plus 9 greater than 0. So we have to solve when this is greater than 0. We don't have to discuss. We have to solve and to give a solution for this quadratic inequality that must be positive. So we are going to search for the positive region because the question is to solve it greater than 0. Now recall, we have to find delta. If delta is negative, no real roots, and we have to take the same sign of a. If delta equals to 0, then we have a double real root and the same sign of a. While if delta is greater than 0, then we have two distinct real roots, and outside the roots is the same sign as a, when between the roots is the opposite sign of a. And here we start. First of all, delta equals to 0 and the double roots or the double root is 3. So we can use the help of the calculator to find this root. Now, because delta is 0 and there is only one root, we put it on the table. We put minus infinity plus infinity. We put the equation here, which is x squared minus 6x plus 9, or this form. And remember, when delta equals to 0, we have to take the same sign of a. So what's the sign of a here? It is plus 1. It is positive, so we put plus and a plus. That means that this inequality is truly always positive, except at 3 it is equal to 0. So the solution is r minus 3, again and again. We need to solve the inequality greater than 0, i.e. we need to find the positive part. We care about the positive part. So the positive part, according to the table, using the rule of delta equals to 0 and taking the same sign of a, which is positive, so we put 0 at the root, positive here and here, then we know that the solution is in this region and in this region. So we can either write it from minus infinity to 3 and append at 3 because we don't have or equal here, union 3, again append at 3 till plus infinity. So we can write it as an interval in this form, or we can write it r minus 3 because we don't need it when it is equal to 0. That's why we are excluding 3 outside of r. So this means all real numbers, but just append at 3, as if we are moving on the number line. We reach 3 here and we continue. So from minus infinity till 3 and from 3 to plus infinity, and the 3 is not included. While if the equation was x squared, if the inequality was x squared minus 6x plus 9 greater or equal to 0, if there is or equal, then the solution is r. Then we need it when it is positive and when it is equal to 0. That's why we don't have an exception, and the solution is r from minus infinity as interval form, from minus infinity till plus infinity. So if there is or equal, then the solution is r. It's always positive and it's equal to 0 at 3. But if there is no or equal, we just take the region where it is positive and we exclude the value where it is equal to 0 at it. Let's continue more examples to know how to benefit from the idea of the sign of quadratic functions to solve inequalities that are quadratic. Solve x squared minus 3x plus 4 greater than 0. So we have to solve this. So first of all, we find delta. Delta here is negative 7. So we are going to use the first remark. If delta is negative, no real roots, and we have to take the same sign of a. So no real roots. Then we just take the sign of a, which is 1 here. So we just put in the table minus infinity plus infinity, and we put a plus sign. But we need it greater than 0, then the solution is r, because we need it positive, and the sign of this is always positive. So that is always true. That means that the solution is r. R means any real number in the set R is a solution for this inequality. That means whenever or whatever I take a number and I evaluate it in place of x, I will get a positive value. Now note, if the question was to solve x squared minus 3x plus 4 less than 0, and the sign here is positive, so if I need to solve it negative when it is negative, where it is negative, and the sign is positive, then directly we say that the solution is phi, empty set, because the sign of this quadratic form is positive, and we need it when it is negative, and that's a contradiction. Then the solution is phi, which is empty set, which means no real solution for this inequality. Here is another example. Solve x squared minus x minus 12 greater than 0. Now, again, delta equals 49, which is positive. Then we are going to use this case. So, we are going to use the case where delta is positive. So we have two distinct real roots. We have to calculate them, and we have to make a table, and we apply the rule of same, opposite, same. So the roots using the calculator are minus 3 and 4, and a is 1, which is positive. That's going to help us to know where same is and where opposite is. So minus 3 and 4 are arranged as follows on the table, from the smaller to the larger, minus infinity here and plus infinity here as usual. Here is the equation, or t of x, or whatever. So we put zeros on the roots, notice, and we apply the rule of same, opposite, same. So the sign of a is positive, then plus, same, minus, opposite, and the plus, same. So same, opposite, same. Okay? And now we need it when it is positive, greater than 0, means plus. Then I'm going to search where we have plus sign. We have it here, and we have it here. So we care about this region and this region. Then the solution is from minus infinity till minus 3 union, because I have two parts, from 4 to plus infinity, and we open at the numbers because we don't have or equal. If we have or equal here, then the solution is from minus infinity to minus 3 closed like this, union from 4 to plus infinity closed like this if we have or equal. But because you don't have or equal, we put it as opened intervals.